Okay, this is the first simulation. This simulation is being used to demonstrate the idea of service level and fill rate. So I think the Excel simulation is the best way to explain this very abstract concept. People also get confused all the time because those are something similar, something closely related to each other. Okay, so both are quality measure indicators that tells how well a provider satisfies the demand. Okay, that's it. Both of them are quality measure indicators. Okay, both measures are measured in percentage. In fact, service level is actually a probability, and fill rate is a fraction. So, but anyway, both are measured in percentage. Let's assume that there are 10 planning period here. The specific condition or specific characteristics of the simulation is number one, we're assuming that there are 10 planning periods. Okay, period 1, it could be week 1, week 2, week 3, it could be year 1, 2, 3, it could be day 1, 2, 3, it doesn't matter. So we have 10 planning periods. And the demand for each period, we use DI to indicate. So D1 basically means demand for the period 1, D2 is demand for period 2, and so forth. And each planning period begins with a constant inventory level S1. So meaning S1, S2, S3, S4, S5, all the way to S10 are the same numbers because we're beginning with a constant inventory level S1. Okay, and then the service level and the fill rate are defined as follow. So briefly, service level is the frequency of non-stack out. See if you can understand what that means. Okay, and the fill rate is the proportion of total demand satisfied. Confused? Yes, of course. I confused a lot when I first get to try to understand what's the meaning of those two. Okay, until I was able to see the Excel simulation that really made sense a lot. In general, in average people, they probably have no idea what's the meaning of it just by looking at those explanations. Okay, so even those mathematical notations will become much easier to understand after you see the simulation. So I'll start a Excel spreadsheet I'll start from the beginning. I'll show you step by step how to model this inventory situation, and from there I'll explain what's the meaning of service level and fill rate, how they are being measured. Okay, so I'm going to start a new Excel spreadsheet. Okay, this is it. Again, this is a in-class exercise, I believe. Therefore, I'm expecting you to follow me to set up this simulation from the ground, from the first step. So I'm probably not going to ask you to set up the thing by yourself ever, other than ask you see if you can find this from this. But I think you understand what my expectations are. Okay, so let's start from the first column. I'm just going to put it as a scenario. Okay, scenario. Probably going to put the inventory level, which is our SI, and demand, which is our DI. Okay, so I said our planning period, instead of scenario, let's just say planning period. Okay, so our planning period, 1, 2, and you know the deal. In the trick, highlight both, and then wait until this turn to skinny dark cross, then drag it all the way until it becomes 10. Okay, and inventory level is something we'd like to pick later. And for the demand, if you recall the characteristics, the demand in each week or each planning period is not known in advance, meaning this is a random. Okay, you arrive it will arrive as a random number. So I'm just going to use, in this case, rand between. Rand between. I'll start from 20 to 40. So your demand will be somewhere between 20 to 40. Okay, but it will never go below 20, never go beyond 40. Because the way that we are using this Excel function here, this is rand between, they will never go below and beyond these two numbers, right? If you still remember. And I'm just going to double click it. So you see a lot of random numbers showing up here. Okay. And I said we're going to decide a inventory level. Inventory level SI. Okay. This number here is going to be a constant number. And constant in the sense that all the planning period is going to be using 34 as their inventory level. Okay, so if you change something here, they all changes. They all change. Do something here, they all change. Okay, this is also changing because this is using the random function. So if you'd like to keep those as a constant or the static random number instead of keep changing every time, you can just do this simple trick. Copy all of them, paste as values only, not paste them as a function. Okay, so as you can see that if you double click, this is not a formula. If you double click, this is a formula. There's a difference. So I'm just gonna move them to overwrite all of them so that those random numbers don't change anymore. Okay, because it will get confused. So this is your inventory level, and all the inventory levels in each week, they kind of follows the inventory level you specified here. Maybe I should just say S instead of SI. Okay, and my question is, what is the service level in this case? Service level. Okay, service level earlier was defined as the frequency of non-stock out. How often a customer, I'm not talking about customers in general, okay? Because we're only paying attention to one person at this time. How often that customer will experience stock out, therefore non-stock out. Okay, trust me, I know what I'm talking. Here, let's take a look at this. Is this a stock out? Is this a stock out? Right? So each time we can compare these two and try to determine whether this particular planning period there was a stock out or no. Okay, so how do you do that? We do that by using the if function. If the demand, okay, is greater than inventory. If demand is greater than inventory, this is called stock out, which I'm going to use number 1 to indicate. Otherwise, it's 0. See if there is any flaw, okay, the deficiency in our logic here. So when the demand is bigger than the inventory level, that's when the stock out happens, right? Meaning there's nothing to sell anymore, nothing you can sell anymore. That's stock out. What about this equal symbol? Should we exclude it or should we include it? Okay, so we should not include this because when the demand matches with the inventory exactly, everybody's happy. There's no stock out happen there. So I think this as is good. Okay, and this is not a stock out. I'm going to double click to fill the rest. So we only had 2 stock out happened in this 10 planning period simulation. So we can do the same non-stock out. Non-stock out. If the inventory level is greater than or equal to the demand, that's when you would have a non-stock out, right? So your inventory is no greater than, I'm sorry, your demand is no greater than your inventory, or your inventory is bigger than or equal to the demand. That's when you have the non-stock out. Okay, so in a sense, when this is a stock out, this should be non-stock out. Okay, so out of 10 times, now we are interested in seeing how many times of non-stock out is here. Total non-stock out is, we can just simply sum it. Okay, simply sum all of them. That becomes a total number of non-stock outs. Okay, I hope everything made sense so far. So therefore the service level here, which is the frequency of non-stock out, which can be also seen as the probability of non-stock out for each customer, is basically 8 over 10, because we have only 10 planning period. Let's say if you did 20 planning period, the denominator should be 20. Okay, so this is what I meant by service level. The frequency, how often, how likely a person will experience a non-stock out. Okay, we're not interested in everybody, every customers here. We're only interested in just one person, okay, because we can actually apply the concept of probability into one person. So service level is the frequency of non-stock out. Now if you take a look at this equation, basically what this is saying is a probability of when the demand is no greater than the supply. Okay, when the demand is greater than the supply, that's where you have a shortage or stock out. So you can actually write it like this, DS, because this part and this part is basically the same. So this part is this, right? We looked at whether demand is bigger than the supply, and here we looked at whether the demand is smaller than or equal to the supply. Okay, so this will tell us what the service level is. So I'm going to change this number slightly. Say I'm going to change it to 30. All right, when you have 30. When you have 30 as the beginning inventory level in all those periods, you will see that the non-stock out has reduced to 6. Therefore, the probability is now 60%. So this probability is the frequency of non-stock out is now 60%. So ideally, you want to have as high as possible. 34, 35. Yeah, so 35, you see all the periods actually have non-stock out, meaning the inventory is adequate in all those planning period. Therefore, service level is perfect at 1%, at 100%. So this is the idea of service level, and I hope you can actually model this thing by yourself for now. But before I let you go, don't forget that we have one more measure to master. The fill rate, as you may recall, is defined as the proportion of total demand satisfied. It's a proportion of total demand satisfied. So before we jump into Excel and start to calculate it, let's figure out what's the meaning of this. So this is proportion of total demand that you have satisfied. So in all 10 planning period, what fraction of total demands in all those 10 periods been actually fulfilled, right? So as you can see that your denominator here is the total demand that you have arrived, right? So that's why we're saying this is what's the proportion of total demand. So therefore, we need to know what's the total demand. And here, it's a summation calculation. So you're summing the smallest number between DI and SI, meaning whichever number is smaller in each period, that you consider that as the demand satisfied. That makes sense because you cannot satisfy more demand than one has in inventory. Okay, if your demand is 10, inventory is 8, there's a stock out situation, you only satisfied or you only fulfilled 8 of those demand because you only have 8 in inventory. Therefore, whichever number is smaller, you consider that as the effective demand that you have satisfied in that particular planning period. Okay, if you think about the other case, when you have a demand smaller than the inventory, right? You have a demand in 8, inventory in 10, obviously you are able to satisfy or fulfill all those 8 demand. Therefore, in order to calculate what is the demand that you have satisfied in any given planning period, you just pick smallest number of 2 to try to calculate the fill rate. So let's come back here. Let's create a new column called demand satisfied. Okay, demand satisfied, or you can just use fulfilled. Demand fulfilled. So that's minimum number. Min stands for minimum between inventory and the demand. All right, if you enter, you double click, then you can come out with a new cell called a total demand fulfilled. That's basically the sum of all of them. Sum of all of them. And let me adjust this. And fill rate, therefore, it's going to be fill rate is going to be total demand fulfilled, sum of all the demand here. Sum of all the demand here. Boom. So your service level is 1, therefore you were able to fulfill all the demand. Let me change this, 32. Okay, your service level is 80, however your fill rate is 98%. In general, both measures, they go together, but they're not always the same, okay, because they're measuring the same phenomena from different perspective. One is telling you what is the frequency of non-stock out, what is the probability of you encountering a in-stock situation, not an out-of-stock situation, okay? We want that number as high as possible. And fill rate is the proportion of demand that is actually satisfied. So hope this makes sense, and you can actually change these numbers into something else and try to see how those things are changing. So the key idea here is, not sure what happened to my shortcut. Control tilde won't open the formula view, but I can always go to formula and take a look at the show formulas. Okay, this is what I have in here if you want to know. But trust me, you won't get anything just by looking at all these, weird looking formula. The important thing is you need to understand the behind dynamic that we have used to model this entire scenario. So obviously you can have a different inventory level in each planning period, right? If you know what the demand is each time. But in this exercise, I'd like to just keep it to a constant beginning inventory level, and then demand is something uncertain, and this is enough for us to show the idea of service level and the fill rate. Okay, I'll just stop here.